Greetings to dear friends, thank you for choosing the BigDark channel for teaching scientific content. Please do not forget to subscribe, like. Tsunami is a series of waves in a water body caused by the displacement of a large volume of water, generally in an ocean or a large lake. Earthquakes, volcanic eruptions, and other underwater explosions, including detonations, landslides, glacier calvings, meteorite impacts, and other disturbances, above or below water, all have the potential to generate a tsunami. Unlike normal ocean waves, which are generated by wind, or tides, which are generated by the gravitational pull of the moon and the sun, a tsunami is generated by the displacement of water by a large event. Tsunami waves do not resemble normal undersea currents or sea waves because their wavelength is far longer. Rather than appearing as a breaking wave, a tsunami may instead initially resemble a rapidly rising tide. For this reason, it is often referred to as a tidal wave, although this usage is not favored by the scientific community because it might give the false impression of a causal relationship between tides and tsunamis. Tsunamis generally consist of a series of waves, with periods ranging from minutes to hours, arriving in a so-called wave train. Wave heights of tens of meters can be generated by large events. Although the impact of tsunamis is limited to coastal areas, their destructive power can be enormous, and they can affect entire ocean basins. The ancient Greek historian Thucydides suggested in his 5th century BC history of the Peloponnesian War that tsunamis were related to submarine earthquakes, but the understanding of tsunamis remained slim until the 20th century, and much remains unknown. Major areas of current research include determining why some large earthquakes do not generate tsunamis while other smaller ones do. This ongoing research is designed to help accurately forecast the passage of tsunamis across oceans as well as how tsunami waves interact with shorelines. Tidal wave. Tsunamis are sometimes referred to as tidal waves. This once popular term derives from the most common appearance of a tsunami, which is that of an extraordinarily high tidal bore. Tsunamis and tides both produce waves of water that move inland, but in the case of a tsunami, the inland movement of water may be much greater, giving the impression of an incredibly high and forceful tide. In recent years, the term tidal wave has fallen out of favor, especially in the scientific community, because the causes of tsunamis have nothing to do with those of tides, which are produced by the gravitational pull of the moon and sun rather than the displacement of water. Although the meanings of tidal include resembling or having the form or character of tides, the use of the term tidal wave is discouraged by geologists and oceanographers. Seismic sea wave. The term seismic sea wave is also used to refer to the phenomenon because the waves most often are generated by seismic activity such as earthquakes. Prior to the rise of the use of the term tsunami in English, scientists generally encouraged the use of the term seismic sea wave rather than tidal wave. However, like a tsunami, seismic sea wave is not a completely accurate term, as forces other than earthquakes including underwater landslides, volcanic eruptions, underwater explosions, land or ice lumping into the ocean, meteorite impacts, and the weather when the atmospheric pressure changes very rapidly can generate such waves by displacing water. Causes. The principal generation mechanism of a tsunami is the displacement of a substantial volume of water or perturbation of the sea. This displacement of water is usually attributed to either earthquake, landslides, volcanic eruptions, glacier calvings, or more rarely by meteorites and nuclear tests. However, the possibility of a meteorite causing a tsunami is debated. Seismicity. Tsunamis can be generated when the seafloor abruptly deforms and vertically displaces the overlying water. Tectonic earthquakes are a particular kind of earthquake that are associated with the Earth's crustal deformation. When these earthquakes occur beneath the sea, the water above the deformed area is displaced from its equilibrium position. More specifically, a tsunami can be generated when thrust faults associated with convergent or destructive plate boundaries move abruptly, resulting in water displacement, owing to the vertical component of movement involved. Movement on normal, extensional, faults can also cause displacement of the seabed, but only the largest of such events, typically related to flexure in the outer trench swell, cause enough displacement to give rise to a significant tsunami, such as the 1977 Sumba and 1933 Sanriku events. Tsunamis have a small wave height offshore, and a very long wavelength, often hundreds of kilometers long, whereas normal ocean waves have a wavelength of only 30 or 40 meters, which is why they generally pass unnoticed at sea, forming only a slight swell, usually about 300 millimeters, 12 in, above the normal sea surface. A tsunami can occur in any tidal state and even at low tide can still inundate coastal areas. Landslides. In general, landslides generate displacements mainly in the shallower parts of the coastline, and there is conjecture about the nature of large landslides that enter the water. This has been shown to subsequently affect water in enclosed bays and lakes, but a landslide large enough to cause a transoceanic tsunami has not occurred within recorded history. Susceptible locations are believed to be the Big Island of Hawaii, Fogo in the Cape Verde Islands, La Reunion in the Indian Ocean, and Cumbre Vieja on the island of La Palma in the Canary Islands, along with other volcanic ocean islands. This is because large masses of relatively unconsolidated volcanic material occur on the flanks, and in some cases detachment plains are believed to be developing. However, there is growing controversy about how dangerous these slopes actually are. Drawback. All waves have a positive and negative peak, that is, a ridge and a trough. In the case of a propagating wave like a tsunami, either may be the first to arrive. If the first part to arrive at the shore is the ridge, a massive breaking wave or sudden flooding will be the first effect noticed on land. However, if the first part to arrive is a trough, a drawback will occur as the shoreline recedes dramatically, exposing normally submerged areas. The drawback can exceed hundreds of meters, and people unaware of the danger sometimes remain near the shore to satisfy their curiosity or to collect fish from the exposed seabed. A typical wave period for a damaging tsunami is about 12 minutes. Thus, the sea recedes in the drawback phase, with areas well below sea level exposed after 3 minutes. For the next 6 minutes, the wave trough builds into a ridge that may flood the coast, and destruction ensues. During the next 6 minutes, the wave changes from a ridge to a trough, and the flood waters recede in a second drawback. Victims and debris may be swept into the ocean. The process repeats with succeeding waves. Tsunami heights. Several terms are used to describe the different characteristics of the tsunami in terms of their height. Amplitude, wave height, or tsunami height, refers to the height of a tsunami relative to the normal sea level at the time of the tsunami, which may be tidal high water or low water. It is different from the crest to trough height, which is commonly used to measure other types of wave height. Run-up height, or inundation height, the height reached by a tsunami on the ground above sea level. Maximum run-up height refers to the maximum height reached by water above sea level, which is sometimes reported as the maximum height reached by a tsunami. Flow depth refers to the height of tsunami above ground, regardless of the height of the location of sea level. Maximum water level, maximum height above sea level as seen from trace or watermark. Different from maximum run-up height in the sense that they are not necessarily watermarks at eye. Thank you for being with us until the end of the program. Be sure to mention your opinions about the educational video in the comments section.